Is the first set of notes in the plate tectonics unit, entitled Layers of the Earth Notes. In this video, you will see a slideshow that contains lots of great information about our topic, and you are responsible for writing down everything that is in orange text, whether you handwrite it or type it. Either way, it's fine. It just needs to go into your digital science notebook. So this set of notes is all about the different layers of the Earth's interior. Crust on the outside. Underneath the crust is the mantle, which you can divide up into different sections, and then the core, which is divided into the outer core and the inner core. Layers of the Earth. The Earth has several distinct layers: the crust, the mantle, the outer core, and the inner core. The crust. We live on the crust, which is the outermost and thinnest layer of the Earth. Compared to the interior, the crust of the Earth is rocky and brittle. The crust is mostly silicon and oxygen. We talked about that in previous units. The most abundant mineral in Earth's crust is the silicates. The silicates are made of silicon and oxygen. The mantle. Beneath the Earth's crust is the mantle. The mantle is the thickest layer. It is made of silicate minerals containing iron and magnesium. The mantle is not completely solid. The upper part is rigid and the lower part is flowing. The crust, together with the upper rigid part of the mantle together, are called the lithosphere. The lower part of the mantle is called the asthenosphere. It is not completely solid and is often described as flowing or plastic. In the lower part of the mantle, there are convection currents with warmer material rising and cooler material sinking. This motion is constant. The core. Below the mantle is the core. The core has two layers, the outer and inner core. Both are made of iron and a small amount of nickel. Keep showing you this image: the crust, the mantle, outer core, and inner core. The outer core is liquid while the inner core is solid. The inner core is the hottest layer, but it doesn't melt because of the immense pressure. The inner core is close to the same temperature as the sun. So who's paying attention? Pop quiz. Which of the following is the hottest layer of the Earth? The inner core, the outer core, the crust, or the mantle? Ding, ding, ding. The inner core. The dynamo effect and Earth's magnetic field. Swirling metal in the outer core creates Earth's magnetic field by generating an electrical current. This is called the dynamo effect. The magnetic poles of the Earth are what cause your compass to point north. Metallic elements inside of rocks also align themselves with Earth's magnetic poles. The magnetic field protects us from some of the sun's more dangerous rays. So if it weren't for the magnetic field, some of the more harmful radiation from the sun would get to us on Earth, but because we have a magnetic field, we are more protected. Here's this picture again of the layers divvied up: crust, mantle, core. but the mantle is divided into the lithosphere and the asthenosphere, and the core is divided into the outer core and inner core. And this image is not to scale. Plate tectonics. Earth's lithosphere, remember that's the rigid crust and upper mantle, is broken up into tectonic plates. The tectonic plates are floating on the asthenosphere, which is the flowing lower mantle. These tectonic plates are in constant motion due to the convection in the lower mantle. So in the asthenosphere, the lower part of the mantle, you have convection currents. The upper part of the mantle, along with the crust, is called the lithosphere together, and that part is floating and moving, and it's divided into plates. The plates are moving very slowly, at about the rate your fingernails grow. Friction between these plates results in geologic activity such as earthquakes, volcanoes, mountain building, and the formation of new crust. Plate tectonics is a major driver of the rock cycle. Rocks melting and cooling, breaking down, hardening anew through plate tectonic processes. And here is a map of the major tectonic plates. And anywhere where there's a plate boundary, you're more likely to have geologic activity. Who's paying attention? Pop quiz. What gives the Earth its magnetic field? The dynamo effect. Alfred Wegener. The scientist who first proposed that continents were moving was Alfred Wegener. I don't ask you to remember too many scientists' names, but there are a couple in this unit that you need to remember. One of them is Alfred Wegener. His theory was called continental drift, and he first proposed it in 1912. His evidence that suggested the continents were moving, that evidence was similar fossils on both sides of the ocean, and similar rock formations on both sides of the ocean, and the fact that the continents appear to fit together like a puzzle. Wegener was the first to propose that all of the continents had once been joined together in one big supercontinent called Pangaea. Two different spellings. And you can see how they kind of fit together like a puzzle here. But Alfred Wegener was ridiculed in his time, in part because he could not explain his theory. He knew the continents were moving, but he could not describe the mechanism. Didn't have the driving force. So other scientists thought he was making stuff up. Joke time. What does Alfred Wegener eat for breakfast? Pangaea cakes. Dun dun. Fast forward about 50 years, and there's another scientist you need to know about. His name is Harry Hess. Technology had been developed called sonar, and sonar allowed for the mapping of the seafloor. It became apparent that new ocean crust was being created at the center of the Atlantic Ocean in a region called the Mid-Atlantic Ridge. Here's a picture of the Mid-Atlantic Ridge, and in fact, there are many ridges like this along the planet, crisscrossing the Earth like the seams on a baseball. And that's where new ocean crust is created. This scientist, named Harry Hess, he figured out that the warm material was rising from the interior of the Earth and indicated that convection was occurring. His theory of plate tectonics identified convection in the mantle as the driving mechanism behind continental drift. You will certainly need to remember that. The reason why the plates are moving is convection in the mantle. And here is another diagram of convection in the mantle, moving the crust on top, or the lithosphere on top. And that's it for this set of notes. And here is a page with all the notes you were supposed to have written down on them. So pause it here and catch up if you need to. And have a great day.